Have you ever stood outside on a strange, still, humid day and thought, this feels like earthquake weather? Maybe the air feels thick, the world unusually quiet, and you can't help but wonder if something is about to happen. It's a phrase passed down through generations, a bit of folklore that tries to make sense of unpredictable events. Grandparents might recall the heavy air before a big quake, and parents might share stories of odd weather before the ground shook. The idea is that before the ground shakes, the sky gives us a warning: hot, calm, or heavy air. People notice the world feels different, and they start to connect these sensations to earthquakes, searching for signs in the atmosphere. This belief is a classic example of our need to find patterns in chaos, especially when facing something as frightening as an earthquake. When disaster strikes, we want to believe there were hints we could have noticed. We look for clues in the weather, hoping for a sense of control. It's comforting to think we might predict the unpredictable, even if it's just a feeling in the air. The myth persists because it feels right. Our senses pick up on something different and our minds connect it to danger. When the air is heavy and the sky looks strange, it's easy to feel uneasy and expect the worst. It's a form of confirmation bias. We remember when odd weather and earthquakes coincide, but forget all the times they don't. Our memories highlight the rare matches and ignore the many misses. The concept isn't new. Aristotle himself believed winds trapped underground caused earthquakes, linking weather above to rumblings below. Ancient thinkers tried to explain the unknown with the tools and knowledge they had. Despite centuries of scientific progress, the myth of earthquake weather still pops up in conversations and news, especially after unusual storms or heat waves. It's a story that refuses to fade, resurfacing whenever nature feels unpredictable. It's a compelling story, but is there any truth to it? Can the weather really warn us of an impending earthquake? Or is it just a comforting illusion? To find out, we need to separate feeling from fact and dive into the real science of what makes our planet tremble. Only by looking at the evidence can we understand what truly causes earthquakes. Let's explore the roots of this myth and what science actually says. By examining both history and modern research, we can uncover the truth behind earthquake weather and see if our instincts are onto something or just chasing shadows. Earthquake weather myths are as varied as the places they come from, stretching across continents and cultures, each with its own unique twist on what the sky or sea might be telling us. Yet, despite their differences, these myths share a common thread: the human desire to find patterns and warnings in the world around us, especially when facing unpredictable disasters. In California, for example, people often talk about earthquake haze, a thick yellowish fog that settles on hot, windless days, and earthquake clouds, dramatic formations that supposedly warn of tremors to come. These beliefs are deeply woven into local culture, fueling a communal anxiety about the next big shake and even influencing how people prepare for disasters. Across the Atlantic in Cornwall, England, folklore links high tides, sudden squalls, or even a strange sulfur smell to impending earthquakes, despite the region being far less seismically active than California. Old sailors' tales speak of the sea turning eerily calm before a tremor, as if nature itself is holding its breath in anticipation. Another persistent myth is that animals can sense earthquakes through changes in the weather, but science shows they're likely reacting to subtle ground vibrations or shifts in the earth, not atmospheric changes. These stories thrive on coincidence. A muggy day followed by a tremor sticks in our memory, while countless uneventful muggy days are quickly forgotten and fade into the background. The pattern falls apart when we look at the data. These weather conditions are common, happening all the time, but earthquakes themselves are rare and unpredictable. The myths are compelling and they make for great stories, but the science tells a very different story, one based on evidence, not folklore. Our brains are wired to connect dramatic events, to seek meaning and warning signs, but that doesn't make the connection real or reliable. The truth is, weather and earthquakes rarely intersect, and the conditions we associate with one often have nothing to do with the other. So, what happens when we mistake one for the other? Let's take a closer look at the consequences of confusing weather warnings with earthquake predictions. In the winter of 2025, California was drenched by record-breaking storms, unleashing relentless rain that led to widespread floods and devastating mudslides across the state. Streets turned into rivers, and hillsides gave way under the weight of the water, leaving communities scrambling to stay safe. As hillsides slid and neighborhoods flooded, social media buzzed with speculation. All this water must be lubricating the fault lines. We're due for the big one. Posts and tweets spread rapidly, fueling a sense of unease and anticipation. The idea that rain could trigger earthquakes felt logical to many. After all, water has the power to move mountains and turn solid ground into flowing mud. It seemed reasonable to connect these dramatic events. News reports showed dramatic footage of mudslides tearing through communities, and many viewers confused this surface instability with the deep hidden movements of tectonic plates. The line between mudslides and earthquakes blurred in the public imagination, but seismologists quickly stepped in to clarify the science. Rainwater only saturates the uppermost layers of soil, while major faults like the San Andreas run miles beneath the surface, far beyond the reach of any storm. The weight of rainwater, even after weeks of storms, is insignificant compared to the colossal stresses and pressures found at fault depths. The forces that cause earthquakes are on a completely different scale. The fear was a classic case of mistaken identity. Mudslides are dramatic, but they're surface events, while earthquakes are deep geological phenomena, born miles underground. The storms and the anxiety they brought showed just how easily we link dramatic events in our minds, even when science tells us they're unrelated. Our instincts often search for patterns, especially in times of crisis. The real cause of shaking remained hidden, far below the rain-soaked ground, where immense geological forces quietly built up over centuries, waiting for the right moment to release their energy. Sometimes, what we see on the surface has nothing to do with what's happening deep below. Nature's mysteries often lie out of sight, reminding us that not every disaster is connected, no matter how much it may seem so. In autumn 2025, fierce Atlantic storms battered Cornwall, flooding towns and eroding cliffs. During one storm, a minor earthquake struck, and locals quickly revived the old belief the storm had awakened the earth. Stories spread, fishermen blamed the angry sea, and people swore the quake hit as a massive wave crashed ashore. The connection felt real, but scientists from the British Geological Survey explained the timing was pure coincidence. Ocean waves, even in storms, create only tiny seismic signals, called microseisms, not enough to trigger tectonic earthquakes. The forces involved are vastly different, like a fly landing on an elephant. This incident shows how our environment shapes our explanations for natural events. In Cornwall, the sea is central to life, so it's natural to look there for answers. But the tremor came from miles beneath the seabed, driven by ancient geological stresses, not the storm above. Sometimes compelling coincidences overpower scientific facts. Seismologists don't watch the weather, they watch the ground. Their main tool is the seismometer, detecting vibrations far too small for humans to feel. Networks of these instruments monitor the planet's seismic activity, pinpointing earthquakes with remarkable precision. Scientists look for foreshocks, small quakes that sometimes precede larger ones, and use GPS to track the slow movement of tectonic plates. They also study fault zones directly, measuring temperature, fluid pressure, and stress deep underground. Earthquake forecasting is about probability, not certainty, and relies on data, not folklore. It's this patient, data-driven science, not strange clouds, that helps us prepare for earthquakes. While earthquake weather is a myth, scientists have studied whether atmospheric changes can influence seismic activity. The focus is on air pressure. Big storms can cause temporary drops, slightly changing stress on the crust. But even the largest storms create pressure changes, tiny compared to tectonic forces. The exception? In volcanic regions, low pressure can trigger small, shallow quakes by affecting magma or underground water. These are rare specific cases, not the deep faults that cause major earthquakes. So, while a storm might be the final straw for a fault already on the brink, it's never the main cause. The real driver is tectonic stress, not the weather. The weather is, at best, an insignificant accomplice. Earthquake weather myths persist because they fit our need for patterns and predictability. Folklore is built on memorable stories and coincidences, while science relies on data and rigorous testing. Studies in California, Japan, and elsewhere show no link between weather and earthquakes. Quakes happen in all conditions, at all times. The earthquake haze myth, for example, is usually just a temperature inversion trapping pollution, not a sign of seismic danger. Major earthquakes are rare, while these weather patterns are common. The scientific method helps us overcome our biases and see the bigger picture. Relying on weather for earthquake warnings is not just ineffective, it's dangerous. The facts are clear: weather and earthquakes are almost entirely separate processes. True safety comes from understanding the science, not the stories. Let's move past the myths and focus on real preparedness. If weather isn't the cause, what is? The answer lies in the relentless movement of Earth's tectonic plates. The lithosphere is broken into plates that slowly shift, driven by heat from the planet's core. Where plates meet, they get stuck, building up strain over years or centuries. When the strain overcomes friction, the rocks snap, releasing energy as an earthquake. This process is silent and invisible from the surface. No weather signals, just physics and rock mechanics. The famous San Andreas Fault is one such boundary, grinding away deep below California. Earthquakes are triggered by plate tectonics, friction, and stress, not meteorology. Weather operates on hours and days, tectonics on millennia. Understanding this difference is key to real earthquake preparedness. The trigger for an earthquake is deep in the rock, not in the sky. After exploring ancient beliefs, modern myths, and scientific facts, the verdict is clear. Earthquake weather is a myth. Earthquakes are geological, born from tectonic pressures miles below the surface. Weather is atmospheric, driven by the sun. There's no proven link between the two. The 2025 events in California and Cornwall show how easily myths persist, but science tells a different story. Instead of looking for warnings in the clouds, we should listen to seismologists. Secure your home, prepare an emergency kit, and have a plan. Earthquakes will come, regardless of the weather. The shiver you feel in the air is just that, a feeling. The real story of earthquakes is written in the ground, not the sky. True preparedness comes from understanding geology, not superstition. Look to the ground, not the sky, and be ready.